Good morning, sir. Let me introduce myself. My name is Bindu and I am from ECA department in Srinivasa Ramanujan Institute of Technology. Subject is DCD, Digital Circuits and Designs. My roll number is 2343180423. Today my topic is Design of Synchronous Counters in Verilog. Introduction to Synchronous Counters. Synchronous counters are digital devices that count in a sequence based on clock signals. They offer predictable timing characteristics due to all flip-flops being triggered simultaneously. Understanding their designs is essential for applications in digital systems and circuit designs. Basic concepts of counting. Counting is the process of incrementing or decrementing a value in a binary format. Synchronous counters can be up counters, down counters, or both depending on the designs. The counting sequence is determined by the configuration of the flip-flops used in the circuits. And next, types of synchronous counters. The most common types of synchronous counters include binary, DCD, and Johnson counters. Each type has distinct characteristics and application influencing the voice of design. The design approach varies based on the counter type, including the number of states and flip-flop configurations. And next, flip-flop used in counters. Flip-flops are the basic building blocks of synchronous counters. Typically, they are T flip-flops. D flip-flops stores the input value on the clock edge, while T flip-flops toggle their state. Choosing the right flip-flop type is crucial for achieving the desired counting behavior. Verilog basics for counter designs. Verilog is a hardware description language used for modeling electronic systems. It allows designers to describe the behavior and structure of circuits succinctly. Understanding the syntax and constructs of Verilogs is essential for writing counter designs effectively. Implementing a basic up counter in Verilog. A simple n-bit up counter can be implemented using a series of three flip-flops. The counter increments its values on each clock pulse based on the current state of the flip-flops. Code examples showcase as how to define the counter behavior and stimulate it. Implementing a down counter in Verilog. A down counter can also be designed using the flip-flops but with different logic. The counter decrements its values on each clock pulse following a specific state transition table. Verilog code for a down counter typically includes conditional statements to control the counting logic. And next, bidirectional counters. Bidirectional counters can count both up and down based on a control signal. This design requires additional logic to determine the counting direction at each clock pulse. Implementing a bidirectional counter in Verilog involves integrating both up and down counting mechanisms. Stimulation and testing of counters. Stimulation is a crucial step in verifying the functionality of the counter designs. Tools like Model Sim or Vivado can be used to stimulate Verilog code and observe waveforms. Testing ensures that the counter behaves as expected under various conditions and inputs. Applications of synchronous counters. Synchronous counters are widely used in digital clocks, timers, and frequency dividers. This serves as essential components in state mechanics, digital circuits, and microcontrollers. Understanding their design is crucial for developing more complex digital systems and applications. Reference John M. 2022 Digital Designs and Computer Architecture. Verilog HDL, a guide to digital designs and synthesis. Thank you, sir.